Good evening, learners. Welcome to another class of Business Data Analytics by CPL Senaka. So let me share the screen. Okay. All right. We are starting just a minute. Okay, welcome to BDA Online Tutor Classname. And this is an online platform that deals with business data analytics, and we guarantee success. Those watching this video on YouTube, please make sure you subscribe, you like, you share, and you click on the notification bell so that you are notified when we post a new video. And I like to say that sometimes you can see that when you are on YouTube, the videos don't match. But we always complete our videos. Our videos are very full. So the thing is, we are having some private videos. So you can liaise with me, and I've said here that any package you buy, you'll be liable for the private videos. And we also have the Excel software, the 2019 one, and we are just selling it at 500. That includes the lifetime activation and the product kit. The thing is that since I'm in Nairobi, like only people from Nairobi can liaise with me if you want, and I'll see. Here you can see there are various packages. I'll not go into the packages. You can just see them. There are various packages and the respective prices. So today we'll be talking about data visualization and dashboards. This is a very important topic under this business data analytics. So we have the subtopics, and we will talk about the introduction, the theory part of visualization. And since you can't talk about visualization without talking about charts, so I took time, and we'll look at the charts, and then we'll go to practical data visualization. From there, we'll go to dashboards, then types of dashboards, then features, then we go how to build a dashboard, then key performance indicators, then practical making of the dashboard. Actually, this Excel file, I've arranged it, how the subtopics are. And I say that even at the basic package, you are liable to get the practice CSV Excel file, right? At the basic level, you are allowed, so you will get this package. So we'll begin with data visualization and reporting. And generally, data visualization is a graphical representation of data, such as charts, plots, infographics, and even animation. These visual displays of information communicate complex data relationship and data-driven insight in a way that is easy to understand. Since you are visualized maybe in charts or graphs, so the data can be understood easily. So you can display your data analysis reports in a number of ways in Excel. However, if your data analysis results cannot be visualized as charts, that may highlight a notable point in the data. Like if you visualize in charts, like charts are what is data visualization in short, because it's a graphical representation. Your audience can quickly grasp what you want to project in the data. It also leaves a good impact. So, and we'll talk about data reporting, the process of collecting and formatting raw data and translating it to digestible format to access the ongoing performance of your organization. Data reports can be basic questions about the state of economy, maybe the income statement, the financial statements, also their reports. And so a dashboard. A dashboard is a way of displaying various types of visual data A dashboard is displaying various way of visual data. Let me admit that one. So like in one place, usually a dashboard is intended to convey different but related information in an easy, digestible format. And the theoretical part here, the theoretical data visualization in Excel, I think I send out the notes. So like data visualization is graphical representation of data. So the benefits can easily be understood. The trends and the patterns can be established easily. And also communicate insights effectively. Like someone can understand what you want to say through data visualization, enhances decision making. So like in data visualization, it makes you see insights that you could not understand when the data had not been visualized, isn't it? And there are three main types of visualization. That is comparison. Comparison compares two or more data sets, usually bar chart, line graph, or scatter plot. And then composition is how the data is composed of different parts or category. They include a pie chart or a stacked bar graph. Like you can say like an income statement. An income statement, you can do composition, visualization, and then the relationship. This shows the relationship between two or more variables, typically use the scatter plot or heat maps. Actually, heat maps, we will talk about them under a chart. So, and good data visualization, you have the following. It should be clear and accurate, relevant to what the message, it must be relevant, not destructive, consistency, and also interactivity. The ability to interact with the visualization, such as zooming or filtering, can help users explore the data. There is something called slicers that is doing with the pivot charts. So we'll go to Excel charts because this one I send out the notes. I think you have them. So visualizing data in charts. In Excel, charts are used to make graphical representation of any data set. A chart is a visual representation of the data. You see, like charts are the main thing of visualization, in which data is represented by symbols such as bars in the bar chart or lines in the line chart. Excel provides many chart types, and Excel recommends chart option. Also, you can see when you go to insert here. Sorry, when you go to insert here, I don't know what here. Let me pin this down. When you go to insert here, because you have not selected the data, but even it can read this data. If you select the data, we have a recommended chart. So this one is an easier way of, instead of thinking which visualization will I take, isn't it? We have the recommended chart, but since our data is not something that can be graphed, so that's why there is no recommendations available, isn't it? Okay, there are various methods of creating charts. The first one is through insert, I've showed you. And the second one is through recommended charts. You know, insert, you can come and this one is the bars, this one is the scatter, this one is the pie chart, isn't it? And also you can do with the quick analysis tab. Actually, let me just move here. I show you the quick analysis tab because that one I can't explain. Where is that data? Like here, when you select this data this way, you see this thing that pops down here. You click the quick analysis, or you can do Control Q. If you click on it, you can see the formatting and the also chart. You can also create charts that way, isn't it? Okay, let me go back. Okay, visualizing data in charts in Excel. Where are we? Oh, this one is practical. Okay, types of Excel charts. We have the column chart. So the column charts are usually used to compare like across few categories or showing data changes over a period of time. Like you can see, like let me say the sales per month. You can use a column chart. A column chart is this one here. You can see we have the column chart. This one is the column chart. So you can use it. And this one is the stacked one because you are going to the clustered. The clustered one, these are useful to compare values across a few categories when the order of categories is not important. Let me say like sales representatives. So you can use a clustered one is here. What is it? This one is the 2D one, the clustered one. The clustered one is there. Compares value across few categories, isn't it? So like they're saying that these charts are useful to compare values across few categories when the order of the categories is not important. Let me say like the sales representative. You'll be creating a clustered one, but they are not they like the x-axis. They are not very important, isn't it? And I remember that a clustered column shows values in 2D, and a 3D clustered one, it has just been there. The 3D class one shows values in 3D perspective, but doesn't add a third axis. Like just shows in 3D. I'll show you when we reach at the example. That's why I'm trying to be a little bit faster. So you can use clustered column charts when you have multiple data series with categories that represent ranges of values, e.g. item count. Isn't it how, like, I was saying, the sales representative, like they have been counted, isn't it? Also, we have the specific cell arrangement. This one is like a scale, like strongly agree, neutral, or disagree, or strongly disagree. This one is like a scale. Also, you can use a clustered one. And these charts are also very important because sometimes you can find them in the theoretical part. They ask you which chart can be used to do this. Actually, there was a question like that one in the last sitting. Names that are not in any specific order, items name, geographic name, or names of people, isn't it? So a stacked one. Now this one goes like up. Let me show you. You must select the data, any data, just for. So this one is the clustered one, like it shows part of the relationship, isn't it? You can see compares part of the whole, shows part of a whole change over time, compares part of a whole across, like it shows part of a whole thing, the whole thing in full. So also the stacked column, we have the 3D and the 2D, and I've talked about 3D and 2D. So we'll go to 100% stacked column. It's the same thing. Yeah, so these are 101. Now they shows part of a total. So that total has been done into percentages, isn't it? So that like you do like a percentage. That's why it's called 100% stacked column, and it's just the same thing. We'll go to, also we have the 2D and the 3D. We'll go to the 3D column. So this is where the difference comes in. The 3D column actually has a depth axis. Like you can see, the 3D column chart uses 3 axes that you can modify: the horizontal axis, the vertical, and the depth axis. They compare data points along horizontal and the depth axis actually. So the horizontal is this way, and the depth, like, let me show you the 3D here. Let me select here the data. Yeah, the 3D column. Also, they have the, like you see, they have gone that way. Like it's like a pole, isn't it? It shows three times, 3 ways. We'll go to line charts. So line chart shows continuous data over time. Like therefore, it's ideal for showing trends in data at equal intervals, e.g. monthly, days, or quarterly, or yearly. That's a line chart. It goes that way. Actually, I think you know about the line chart. In a line chart, category is distributed evenly along the horizontal axis. The value is distributed evenly along the vertical axis. Like you see, you can't go from 1 to 5. It will be like 1, 2, 3, 4. And if it's 10, 10, like it will be 10, 20, 30, 40. They're evenly distributed, isn't it? Okay, so there are different types of line chart. So we have the line chart and line with markers. So line chart indicates individual data values. Line chart works best when you have multiple data series. Line chart can show trends over. We talked about that one. Evenly spaced category. A line chart can be with or without markers. You can use a line chart without markers when the order of category is important, where the categories or if the values are approximate, and you can use with markers when the category also is important, and there are only few categories. There are not many categories. This one is where the change comes in. So you can see actually here we have the line chart. So this one we have just the line one, and here we have with markers. Also that one stacked with markers, isn't it? Let's talk about the stacked with markers. So the stacked with markers indicate individual data values. Stacked line charts can show trends of the contribution of each value over time, like how each value has been contributed. I told you stack shows the part of the composition, the relationship to the composition of the whole thing, like to the total of it over the total, isn't it? So you can use a stacked line chart when there are many categories or if the value is approximate. You can use stacked line chart when you only have, like here we have the without and the with. So with when only you have the few categories, isn't it? And reading a stacked line chart can be difficult as they sum the data, which might not be the result you want. It may not be easy to see the lines are stacked. Like you can't see, like the stacked column. You see how it has gone, but where is it? Here you can see the stacked. You see, but when you come to the line chart, here to the line chart, actually you can't see how it's stacked, how it's over the total, isn't it? So here is the stacked line and the 100% one. So this one I told you the total has been done to be 100. And we also have the 3D one. This 3D is the same thing. You can see the 3D line shows each row or column of data as a 3D ribbon. The 3D line can show trends over. Actually, something is missing there. A 3D line can chart has horizontal, vertical, and data. Actually, when you hear of a 3D has three dimensions. That's the full of 3D, isn't it? So we'll go to pie chart. So pie charts show the size of items in a data series proportional to the sum of items. The data points in a pie chart are shown as a percentage of the whole pie, isn't it? And just a point or just to say something, but I changed the way we were doing it. We were doing it like just revision. So I changed. We went back to the concept so that actually someone comes with the concept, knowing actually this is what this does, instead of just saying this does this, isn't it? So that's why and we have just updated all our notes, every topic. So if you have not paid, you may consider paying. Because now we are very, that time I've been doing the research. And so we'll go to the, actually, so these are the examples of the pie. We have the pie and the 3D pie. Pie charts show the contribution of each value to a total value. So you know the pie charts, like each part takes it up when the circle is round at 360. So click on the slice that you want to emphasize, put it in the chart. Like maybe you have created a pie chart and you want to emphasize on a certain slice of it. So you just click on it and you pull it out of the chart. Using this chart shows the proportion of the whole pie. Isn't it? Everything has a is proportionate, so that when everything is in, the circle is full. Use this chart when the number is equal to 100%. The chart only contains a few pieces. Like you can't use a pie chart when the data is very big, like it's very long. It's not just, so the pieces are very many that you can't see even the percentages, isn't it? Pie chart or pie of pie and bar of pie. Pie of pie or bar of pie chart shows pie chart with the smaller values pulled out of the secondary pie or a stacked bar chart. We make them easier to distinguish. This one I'll show you just here. So this one is the pie, the pie of pie, like you see, like it shows this percentage to this one, this one. I don't know if you get that. Like here, they're just saying pi of chi with smaller values pulled out of the secondary pi. So the values have been pulled out of the secondary pi. Use this chart to show proportion to the total value. Take some values from the first pi and combine them in the second pi in a stacked bar. I told you stacked shows the, like, I think you've gotten that one. To make small percentages more readable, highlight the values in the second pi. Like you can see, maybe you have many values, so the percentages are not really readable. So you need to do something like you introduce the pi of pi or both pi so that those percentages are very readable. So the percentages are called data labels. When we reach to presenting, we'll show you data labels. So we have the donut one. This one, donut one, is also under pie chart. It's here, the donut chart. So the donut chart shows the size of items in a data series proportional to the sum of items. The donut chart is similar to the pie chart, but it contains more than one data series. You see, on a pie chart, you can't enter like many data series. Like let me show you like how a data series is done. Or let me take this up here. Like when I say, like, let me say the gross profit, you see, when I take this way, this one is a data series, it has gone that way. So you can't, in a pie chart, like you can't take two. You can't take two, but in a donut one, you can take two of them. You see, in a pie, this one is how the pie chart comes in, just simple as that. Control X. Okay, let me try the other one. So I'll hold on my control so that I doesn't leave the selected one. So I'll take the total expenses also, and I'll go to insert. Then I'll go to pie chart here. Then I'll go to donut. You see, I think now you're getting, this one can show like two or more data series, but a pie chart cannot show two or more data series. Let's go back. We'll reach there. We'll reach there. Don't worry. We are here Excel charts. So we'll go to bar graphs, and our bar graphs are just same to column charts. The difference is that one is vertical and the other one is horizontal. So the bar charts are vertical. Like you can see, it illustrates the composition among individual items. A bar chart is typically displays categories along a vertical category or axis, and the values along the horizontal value or axis. So the categories will be vertical and the values will be horizontal. It's the opposite of column, And I think the clustered one, the stacked and the 100% stacked, those one we talked about them, is just the same thing. We'll go to area chart. Area chart is used to plot change over time, years, months, or days, or categories, and draw attention to the total value across the trend. By showing the sum of plotted values, an area chart can show the relationship of part to a whole. You can use area chart to highlight the magnitude of change over time. Maybe like, let me show you the one, but I think they're just here. I can go to recommended. They tell me no, I come here. So where is the area chart? Here. You can see like it changes. Like let me say the stocks. It's like, but we have the one for stocks. Don't confuse. We have the one for stocks. Like it shows the changes over time. You can see it shows the changes over time and can be used to show part of the relationship. Part of the whole, isn't it? So we have the area and the 3D area. So these charts are useful to show trends over values over time of category data. An area chart shows the value in 2D. A 3D area chart shows the value in 3D. A 3D area chart uses 3 axes. I said 3D is 3-dimensional. You can use the area chart when the category is not important to highlight the magnitude of change. And we also have the stack one. So the stack one shows are useful to show trend of contribution of each value over time, how each item has been contributing to the total. Like it shows parts of the whole, the relationship parts of the whole, isn't it? So like the stacked one, so they have the total value. They have the total value. You can use structures to highlight the magnitude change or draw attention to the total value across trend. And also have the 100% one. I told you the 100% one is being done at 100%. So the total has been converted into percentages. Also can be used to draw attention to the total value across trend or highlight the magnitude of change to the percentage that each value contributes. So the percentage, the 100% one is just the percentage is different. So we'll go to scatter. This scatter one comes in a regression analysis. So scatter X or Y charts are typically used to show for showing and comparing numeric values like scientific, statistical, or engineering data. So here is where statistical come in, the regression analysis statistics. So a scatter chart has two values, X, the horizontal X, the X-axis and the Y-axis. It combines X and Y values into a single data point and shows them at irregular intervals. This one is the scatter. You see like it takes the X and Y but shows them at different data points, isn't it? So you can consider using a scatter chart when you want to change the scale of the horizontal axis. You want to make the axis a logarithmic scale. Values for horizontal axis are not evenly spaced. You want to adjust the dependent axis scales of scatter charts to reveal more information about the data that include pairs or grouped sets of values. You want to compare many data points regardless of the time. So this one shows many data points, or the more the data you include in a scatter, the better the comparison. Like takes more data. You can use a scatter chart when the data is many. So a scatter chart is used to compare at least two sets of values of pairs of data. Scatter chart shows the relationship between set values. That's why it's comparing the X and the Y at different points, isn't it? The two sets of values or pairs of data. Use scatter charts when the data represents separate measurements. Like in management accounting, you can see the cost and the total cost and the variable cost, isn't it? They can be two, or let me say there's the quantity and there's the quantity sold and there's the revenue. You see, they are very separate measurements. This one is in money form and this one is in goods, maybe say in goods. They are very separate. They are not measured the same. So types of scatter charts. We have the scatter charts with smooth lines and markers and scatter charts without smooth lines. So scatter charts with smooth line and markers and scatter charts with smooth lines display a smooth curve that connects the data points. A scatter with smooth lines and markers and a scatter with, I think here I repeated myself, with smooth lines are useful to compare at least two sets of values or pairs of data. So like we just have here under the scatter one, we have the one with markers and the one without markers. And we have the one with straight line with markers and a straight line without markers, isn't it? So without smooth line, so use scatter with smooth lines and markers to scatter, and scatter with smooth line charts when the data represents a set of X and Y pairs based on the formula. Use scatter with smooth line and markers when there are few data points. And then you can use when the lines are when there are many data points. So you use the one with markers so that the markers can be visible. And so straight lines with the line markers and straight lines. I think this one is this one is with straight line. So I've shown you the one with straight line. So the straight line connects data points with straight line. Scatter with straight line, markers and scatters with straight line are useful to compare, like the one with markers and just the straight line. I showed you the two are useful to compare at least two sets like how I say the X and the Y. And so without a smooth line. So you can use this one. Here are the usages. You can use with straight line and markers or straight line alone. And I have like 10 minutes. We'll get back. When the data represents separate measurements, I've talked about the separate measurement. Use scatter straight line with straight line and markers when there are few data points. When the data points are very few. The other one with the smooth line is when the data points are many. When the data, like use the scatter with straight line. So this one is with straight line alone. You know, we have like here, we have like straight line with markers and a straight line alone, isn't it? So you don't confuse them. So we'll go to bubble chart. Also, bubble chart is under the scatter, but it's a big bubble. So a bubble chart is like a scatter chart with additional third column to specify the size of the bubble. It shows to represent the data point in a data series. So like step one, so here like place the X values in a row or column, then place the corresponding in adjacent row or columns. Like they can't be alone, like one is this way and the other one is this way. The others are just the same. So the bubble one is also under scatter one. Here is the bubbles one. Okay. And there are two. So, and I will talk about I think I tried to talk of all the charts. We have the stock chart. So this one is about the stock prices. Actually, but we just peruse through. Like we have high, low, close. High, low, close stock chart is often used to illustrate stock prices. It requires 3 series of values in the following order: high, low, then close. And also the other, like they are just that way. And they are here also. Let me go to recommended chart, then all chart. Let me move this one down. The zoom is. So we are on the stock chart. It's here. You can see here. We have the high, low, close, high, low, close. And we have the open, high, low, close. Yeah, the open, high, low, close. And also the high, low, close and volume open, volume high, low, close. Not open. Let me be okay. I'll do Control X. So like that's the order. Like how these are like stocks. Sometimes stocks go up and sometimes go low. So like when we open, so we have the one that we start when we are high. We have the one that we start when we are open, and we have the volume one. Isn't it? This one actually you can just peruse through. You have not seen it being examined, but just for the sake. And we also have the high open and the high, but they are just the same. The key difference is the volume. They are these two. Key difference is the volume, isn't it? So we'll go to surface chart. So surface charts are useful when we want to find the optimum combination between two sets of data. As a topographic map, the colors and the patterns indicate the areas that are in the same range. Like they indicate the like it's like a map, but let's not say a map because we have that one. I'll go to insert. Yeah, I'll go to recommended charts. Sorry. You must actually select any data first. So I go to this one, and here is the surface one. You see, like it's not like a really map, but it shows where the data are. So we have the 3D one, the wireframe 3D, the contour, and the wireframe contour. And also this one I've talked about them here in this. And I remember if maybe you are watching this video on YouTube, these Excel files we have them, and they are very affordable prices. I think at the start of the video you saw it. So to create a surface, we ensure both categories and the data series are numeric. Like it must be numeric value. So what they're saying in this chapter. So we have the 3D one. which can be imagined as a rubber sheet stretched over a 3D column. Like a rubber sheet, you've seen something has been blue like here, because we chose that one. It's like it's stretched like over. So it's typically used to show a relationship between large amounts of data that may otherwise be difficult to see. Color blanks in the surface chart don't represent data theory. Indicate the difference between data values. You can use the 3D when the both series categories and series are in numeric. Maybe say the categories are in years, that's numeric, and the series maybe they are the revenue, also they are numeric. To show trends in values across 2 dimensions and have continuous curve. We also have the wireframe. This chart shows only the line, It doesn't show everything. It shows the line. You know, the first one, the 3D one, like it was like this one is like a wire. Let me say like a wire. The other one it was like a rubber sheet. But the wireframe one is like a thread one, like a line. It shows in a line. And also the contour one is similar to the 2D topographic maps. In a contour chart, the color band represents data ranges of the values. The lines connect the interpolated points of equal value. Okay, you can use the contour to show 2D top view or 3D surface chart to represent ranges of values using colors when both categories are in numeric. Also here, like this one, they must be numeric. That one is the main thing. They must be numeric. And we'll go to radar chart because I want when we come back, we start on practical data visualization because we have like 5 minutes. So 3 minutes. The radar chart compare the aggregate value to several. So the aggregate is like the average to the several data series. So we have a radar and a radar with markers. A radar and a radar with markers shows values relative to the center point. Radar with markers shows with the markers for the individual points, and radar shows without the marker for individual points. You can use the radar and radar with marker chart when the categories are not directly comparable. And we also have the field one. So the field one is the area covered by the data series is filled with color. But it's the same thing, the radar. And then so we have the combo chart. So these combo charts are like you've combined the 2 charts, maybe say a clustered column and a line chart like here. You can use combo chart when the numbers are in your data vary widely from data series to data series, or you have a mixed type of data, for example, price and volume. You can use combo chart. So you show one like for the price and the one for the volume. You can plot one or more data series on a secondary vertical axis. So when you combine, there is the one that will be on the primary axis and the one that will be the two. Like let me say the price and volume. There's one that will be on the primary axis and there's the one that will be on the secondary axis. So there are different methods of combining. So you can combine a clustered column with a line chart. And a clustered column line chart is used to highlight the different types of information. Clustered column line chart combines a clustered column and a line chart, just self-explanatory. You can use the line chart when you have mixed type of data and clustered line on a secondary axis. This one is actually another one. Let me do this control board. A clustered and a line on a secondary chart are used to highlight different types of information. The scale on the secondary vertical axis shows the values of associated data series. And I think we've talked about the clustered column and the line chart. So like you can also combine the stacked area and a clustered column. We have less. Then spark lines. Spark lines are just here. Here the spark lines. You just add them in front of the data. Then we have a pivot chart. Like I think we'll just resume because the time is up. Those on YouTube, we don't upload all videos on YouTube, so we have also private videos. That's why when you watch the videos, someone asked me why are the videos not full. The videos are full, but you must pay so that we can connect you to the